Moving right along, we're going to discuss our different types of radioactive decay. We do have three main types. We have alpha decay, beta decay, and gamma decay. Alpha and beta decay are going to refer to the particles that are being shot off, while gamma decay is going to be referred to as the actual light radiation that is being given off. So let's start with alpha decay, and probably the easier of the two. Alpha decay was going to require a little bit of math here. Basically, our isotope is going to give off what is called an alpha particle. Our alpha particle consists of 2 neutrons and 2 protons. And if you sit there and you think about that, 2 neutrons and 2 protons together is actually the nucleus of a helium atom. You can think of helium as having 2 protons. Not always, but sometimes it has 2 neutrons. So you can think of an alpha particle as the same thing as an helium atom without the electrons. If I give off this, then I am losing 2 neutrons and 2 protons. If you recall, your neutrons and protons each have an atomic mass unit of 1. So therefore, when I go through alpha decay, I lose 2 neutrons, lose 2 protons. I'm going to be losing 4 mass, 1 for each neutron, 1 for each proton. I am also, because I'm getting rid of 2 protons, I'm going to lose 2 atomic numbers. So for example, if I have thorium-232, this is a thorium isotope with a mass of 232. It's going to go through alpha decay. Again, this is going to happen spontaneously, and it's just because thorium is an unstable isotope, or at least thorium-232 is an unstable isotope of thorium. It's going to give off an alpha particle. It's going to lose 2 neutrons and 2 protons. In doing so, I am going to lose a mass of 4, so 232 minus 4 is going to give me this 228. And I'm going to lose 2 atomic numbers. So if I look up on my periodic table, find thorium, and go down 2 elements from it, it is radium. So thorium-232 goes through alpha decay, gives off an alpha particle, which is pretty much a helium nucleus, and it becomes radium-228. So here we have example of polonium going through it. Polonium-240 is number 94 on our periodic table. It's going to give off an alpha particle over here, which is a helium nucleus. It's got a mass of 4, and it's got an atomic number of 2. Polonium's atomic number is going to go down by 2, and its mass is going to go down by 4. And it's made up because this is what it's losing. This symbol here is our abbreviation for alpha. This is the lowercase alpha. It's a Greek letter. Polonium is going to become uranium. Beta decay is a little more complicated. There actually are 2 types of beta decay. There's type 1 and type 2. So beta decay, your isotope is going to give off what's known as a beta particle. Do not get that confused with an alpha particle. They are very different things. Your beta particle is basically an electron in our cases. So what's going to happen is your neutron is going to spontaneously become a proton. Just out of nowhere, it's going to get a charge, and in doing so, it's going to make my nucleus have more of a positive charge and therefore unstable, and it needs to eject out an electron. So our mass is not going to change in this case because a proton and a neutron have the same mass. All I'm going is from a neutron to a proton. However, my atomic number does go up 1 because I'm not really gaining a proton. I'm losing a neutron and turning it into a proton. So I have 1 more proton than I started with, and therefore, again, protons define what element is what, and therefore it goes up 1 atomic number. So, for example, if I have carbon-14, this is an isotope of carbon that has a mass of 14. I'm going to go through beta decay and shoot off an electron. In doing so, I am going to go from having 6 protons to 7 protons because my neutron changed to 1, and therefore I become nitrogen. Note that my mass did not change. I still have 14 of each. I just went up 1 on my periodic table. So my mass, or not my mass, my atomic number increased by 1. So here's another example. Here is radium. Radium is number 2, has a mass of 228. It's going to go through beta decay, and it's going to become actinium, which also is going to have a mass of 228 because an electron down here, my beta particle, it is not really affected by mass. It's 1/2000th of a mass unit. It's neglected, and we kind of ignore that when we calculate mass. So our mass doesn't change. However, our atomic number does go up by 1 because one of these neutrons became a proton. Gamma decay, this is going to occur both during alpha and beta decay. So it happens simultaneously with both of these. This is the actual light energy that is being given off. It is a ray of light. However, it is so high on our spectrum of light that you cannot see it. It's actually higher than X-rays. It's a gamma ray. It does not have a charge. It's not going to change the mass, and it's not going to change the atomic number. It is just light being given off. Gamma decay, again, happens during both alpha and beta decay, but there's no particle really being released. It's just a light. So here we have a nice picture that you're going to see a lot of in the next video. We do have our radioactive atom. It's going to go through radioactive decay. It's going to give off a particle, whether that's an alpha particle or a beta particle. And it's going to give off the energy, which is your gamma radiation or your gamma decay.